Okay, so we are on the polygons and quadrilaterals unit, and we're going to start notes 2. And the first quadrilateral we're going to discuss is parallelogram. Parallelograms are all-encompassing; they're not specific. Squares, rectangles, and rhombuses are all parallelograms, but they have more rules to make them specifically a square, rectangle, or rhombus. So we need to talk about the 5 basic rules that prove that a quadrilateral is a parallelogram. And these are 5 that you're going to have to remember. So take careful notes here. I'm going to give you words and pictures. The first piece of information that you need to know is that a parallelogram has 2 pairs of opposite sides that are parallel. So what that means for us is that if we have a shape and we think it's a parallelogram, then one way that we can prove it is by having one set of parallel sides and then another set of parallel sides. And as we've discussed in the past, the arrow on the line means that they're parallel. Also, what that means is this angle, and we'll talk about that in a minute, but this angle is congruent to this angle, and these 2 angles equal 180. And that's another way that we can prove it. Okay. Not only do the opposite sides have to be parallel, but the 2 pairs of opposite sides also have to be congruent. And so when we draw the parallelogram, this side has to be congruent to this side, and this side has to be congruent to that side. So as far as sides go, the opposite sides have to be parallel, the opposite sides have to be congruent. So that's the first 2 rules. The third and fourth rule have to do with the angles, and you should know this based on what we just talked about. The third rule is that alternating angles have to be congruent. And that's that alternating interior principle that we talked about back in chapter 3, I guess now. And so if we have the parallelogram and we number the angles 1 through 4, then obviously angle 1 and angle 3 need to be congruent, and angle 2 needs to be congruent to angle 4. Okay? Pretty common sense. And then we also know that angle 1 and angle 2 together have to equal 180. And that angle 2 and angle 3, or angle 3 and angle 4 also have to equal 180. But then we also know that angle 1 and angle 4 have to equal 180. So angle 2 and angle 4 have to equal 180. So any 2 angles in a row have to equal 180, and that's our fourth rule. Consecutive angles are supplementary. And we called that SSI or CI back in the day. So 4 rules so far: 2 pairs opposite sides parallel, 2 pairs opposite sides congruent, alternate angles congruent, consecutive angles supplementary. And so then the 5th rule is in a parallelogram, and that's any parallelogram, the diagonals should bisect each other. So when you cut across the shape from corner to corner, then this side is congruent to that side, and this side is congruent to that side of the diagonals. So diagonals bisect. So these are the 5 rules. Okay, 2 pairs opposite sides parallel, 2 pairs opposite sides congruent, alternate angles congruent, consecutive angles supplementary, and then diagonals bisect. So when you're writing these rules on a quiz or a test, you can just put two pairs opposite parallel, 2 pairs opposite congruent, AI, SSI, and diagonals bisect. Be careful. Even though these properties look like stuff that you've had in 8th grade, they're different. This is proving that a quadrilateral is a parallelogram. So before you were just told this is a parallelogram, and then you didn't have to worry about the properties. Now we actually have to be able to prove that a diagonal is indeed a parallelogram, or that a quadrilateral is indeed a parallelogram. So I want you to go ahead and I'm going to put all 9 of these up on the screen. I want you to go ahead and pause the video right here. And what we're going to do is you're going to copy these 9 pictures, and then we're going to discuss whether or not these are parallelograms. So go ahead and pause the video, copy these 9 pictures. Okay, now that you guys have copied the 9 pictures, what I want you to do now is you're going to pause the video again, and I want you to take 2 or 3 minutes, and I just want you to tell me yes or no, are these 9 pictures a parallelogram? If it's yes, I want you to tell me which rule it follows that made it a parallelogram. If it's no, then it's going to be any I. And so what we're going to do then is we're going to talk about these 9 pictures and the rules. If you want, I'll go ahead and do the first, and then you can pause. So number 1, these angles are all congruent. And so, yes, this is a parallelogram, and the rule is opposite angles. Okay, wow. Opposite angles are congruent. That's the rule. So go ahead and pause the video, do 2 through 9, and remember, if it's no, just put any I. If it's yes, just tell me why, and then we'll check these together. Okay, so you guys took a minute and did the 2 through 9, hopefully. Number 2, it is yes, because the diagonals bisect. Number 3 is yes, because opposite angles are congruent. Number 4 was no, because of any I. Number 5 is tricky, because you have a congruent side here and a parallel side here. So we're going to come back to number 5. We're going to talk about 5 and 9 here in a little bit. Okay. Number 6 was no. We did not have enough information. Okay. We did not have enough information. Number 7, yes. Opposite angles congruent. Number 8 was yes, because the diagonals bisect. And so now we got to talk about 5 and 9. 5 and 9 are both yes. And I know that these two were probably very tricky, because it felt like there was only one set and you needed to have 2. Here's the deal. If 2 lines are parallel, you always got to think about train tracks. And do you see how this is a set of train tracks? If these 2 lines are parallel and these 2 sides are congruent, then automatically these 2 sides have to be congruent and these 2 sides have to be parallel. So you have 2 ways that you can prove this by only having 1 pair of each. They can be alternating, or they can be together. But either way, you're going to prove that, okay? So basically, like I say, if these 2 are congruent and they hit the parallel lines at the ends, then automatically it makes the other set happen. And so this is both of the sides principle. So parallel and congruent sides. And this is also the same thing. Parallel and congruent sides. These 2 are the trickiest, okay? And it's because, again, you got to have if you have parallel and congruent sides together, then you can make it happen. That's in direct contrast to number 6, where we don't know anything about the parallelity of these two lines, so therefore they could be off by just a little bit. We don't know anything about the length of these two diagonals either, and so it wasn't enough information to be able to prove anything. And so that's kind of the difference, okay? But really, what is this trying to get to? And that's where we use a little bit of algebra to solve for some missing information. So if this is a parallelogram, what two things in this picture are equal? Well, 4y is equal to 6y minus 42. So just as we've done in the past, we set those equal and we solve for y. Well, once we do that, we know y is equal to 21. If 4y was equal to 6y minus 42, what is 6x minus 12 equal to? Well, obviously 2x plus 36. So we set those equal, and we can solve for x, and x is going to equal 12. The same thing is true of the diagonals. Remember, if it's a parallelogram, the diagonals bisect. And so automatically, this is congruent to this, and this is congruent to this. So you can just set x equal to 5x minus 28. And when we solve for that, we get x is equal to 7. 5y is equal to 2y plus 12. And we solve for that, and we know that y is equal to 4. And so that's the important thing, is being able to look at two things and set equal to each other what's equal to each other. You may have to get in situations where you have to add these two together or substitute in using some of the old algebra skills, but it's not overly hard algebra stuff. But I'll definitely be around if you want to help, if you need help with that. The other thing is here, what I didn't talk about was how did I know that these were opposite angles congruent? Well, 40 was opposite of 40, so that was fine. But this angle has to be 60. And so therefore this angle has to be 60. Remember the old triangle rules? And so that's how you know that it works out, because you use your triangle rules, you use your other rules, you use supplementary rules, and it all works out. So let's go to what you're going to have to do in the workbook today. On page 151 in your workbook, we're just proving stuff about parallelograms. So 1 through 6, this should be easy. You're just proving the angle stuff. Remember, opposite angles are congruent. Consecutive angles equal 180. So in 1 through 6, you're just working on that idea. In 8 through 12, you're working on what is the congruent sides. What are true about congruent sides. And so if AE is equal to 3x and DC is equal to y, DE is equal to 4x, and EB is equal to y plus 1, well, 3x is equal to y. And so we're going to put 3x here, and so that 4x is equal to 3x plus 1. So then we can solve for x in number 8. And when we solve for x, we realize that x is equal to 1. Well, if x is equal to 1, well, what's 3 times 1? 3. Y is equal to 3. So I took the 3x to see 3x was equal to y. So I took the 3x and substituted it in for y in the other problem and was able to solve for x that way. In 9 through 12, you're going to have to use the same picture. You might have to substitute, but you're going to be solving for x and y in both. Okay? Again, if y is equal to x plus 5, then you're just going to be using x plus 5 here, for example. I'll tell you what, we're just going to stop at number 9. So you're just going to do number 9. And then we're going to do 10 through 12 whole class. If so, y is equal to x plus 5. I want you to substitute it in and then go back and solve it. And then on the back, 17 through 24, again, it's just making sure you understand the rules of how you find the measures of the angles, given that it's a parallelogram. And then once you're done with that, I think you guys could really easily do 1 through 5. Yeah, I know this. I said they're advanced, but I really would like to see you try to do 1 through 5 on page 153, especially since I cut off the other 3 problems. All right. Well, good luck. Any questions? Make sure you stop and ask me.